Hi guys, welcome back to 3 Inquisitive Kids, and in this video we are going to be learning all about estimation. So the 2 learning goals for today is, first, understand the basic methods of estimation, and 2, able to use estimates to solve word problems. So observe and think introduction. A new park was built in the city. It is known that the length of this park is twice its width, and its area is 400,000 meters squared. So, about how long is its width, and is it up to 1,000 meters? So this is the area, and we use S to represent area sometimes, but any letter is really fine. So is the width up to 1,000 meters? Try to express this with an algebraic expression and just try to solve it yourself first and see if it's at least 1,000 meters long. Okay, so let's look at this. If this is 1,000 and this is 2,000, this would be 2 million, which is like way greater than 400,000. So the width of the park isn't up to 1,000 meters. So really, it's asking, is it up to 1,000 meters? Well, let's first try. So let's just first try and pretend that it is 1,000 meters and see if, it applies. In this case, it does not, so the answer is no. The width of the park isn't up to 1,000 meters. 2. If the required margin of error is less than 10 meters, what is its width? And also, here's a quick hint. Let x represent the width of the park. Also, if you are confused of what margin of error means, is that, when you're manufacturing something, say like in a factory, not every single product that you produce is going to be exactly the same. So, say we are producing parts, this is a nail that I'm producing, and say that it's the length is just 1 centimeter. Now I can't have one that's about 10 centimeters. Wow, that centimeters. No, that's like way too big. So maybe my margin of error would be 0.3 centimeters, which is like, the greatest it can be is 1.3 centimeters. The smallest it can be is 0.7 centimeters. So it's that range. You can't have like a huge one at 10 centimeters. That won't qualify. So I hope you kind of understand what I mean when I say margin of error. So now you can go on ahead and solve the problem. Okay, so if we look at this, yep, we can demonstrate this as x and 2x. So x times 2x is equal to 400,000, which means that 2x squared, remember we are right now multiplying, you can think of this as x times 2 times x, which is 2x squared is equal to 400,000. So if we divide both sides by 2, x squared is equal to 200,000. So x is equal to the square root of 200,000. So about how much is 200,000 though? This is the basics of estimation. Question: are the following results correct? How do you know? Besides, if you are really confused with this symbol right here, you might think it looks really like a equal sign. This is an equal sign. But if you see it squiggled like that, it just means approximate. So approximately, what is it? So there you go. You can start thinking about this by yourself. So for me, what I would do is just see, I know that if I multiply, if I like square each side, this is 0.43. But so if I square this side, it's 0.43, but if I square this side, it's 0.004356. So actually, this is greater than 0.066, which means it's false. If I look at this, I'm going to be cubing. So if you look at this, it's interesting because we already know that cubes and square roots are inverse operations, which makes them cancel out. So is cube roots and cubes. So if you actually cube each side of this, you see that the cube of the left side is 900 and the cube of the right side is 884736. So you immediately know that the cube root of 900 is less than 96. 3. The square root of 2536 is about 60.4. So 60.4 squared, if we look at that, it's 3648.16. And on the left side, if we square it, it's just 2536. So the square root of 2356 is less than 60.4. So actually, the relationship between two numbers can be compared by direct calculation, which means I'm gonna multiply both sides by I'm gonna cube both sides, or I'm gonna square both sides, and then you can just compare them. So here's some more that I like. Okay. Yep, we have this. So another way we could do this is that the relationship between two numbers can be compared through estimation, which is what we're going to be covering today. So this, like a good example is the second one. If so, we are rounding each of this to 1,000, and we know that this is less than 1,000, which means that, and we already know that the cubic root of 1,000 is equal to 10, which makes the cubic root of 900 less than 96. So we also know that, the cube root of 2,536 is about 60.4. Is that right? Well, 60.4 is about 60. So 60 squared is 3,600, which means that 3,356 is less than 60.4. So key point summary. There are different methods of estimating irrational numbers. So determine the integer part of the irrational number by using the inverse operation of the power in square root, which means, we would square both sides to get rid of the square root, or cube both sides to get rid of the cube root. And another one is just determine the decimal part according to the margin of error, which is something we just learned. So, how can you estimate the square root of 12.5 with a margin of error smaller than 0.5? I mean 0.1. So basically, it means the same thing. So basically, it means the same thing. So basically, it means the same thing as you estimate this to the nearest 0.1, which is something you might be more familiar with. Okay, so let's do this together. We know that if we square this, it is 12.5. And we know that 12.5 is greater than 3 squared, but less than 4 squared. And this is 9 to 16, by the way. So we know that this is greater than 3, but less than 4. which means that the integer part of the square root of 12.5 is 3. And this is greater than 3.5 squared and less than 3.6 squared. And when you're doing this, it's fine if you have a calculator with you. Just, yeah. And which means that 3.5 is less than 12, the square root of 12.5, but 12.5 with the square root of 12.5 is less than 3.6. Okay, so the value of the square root of 12.5 is close to 3.5 or 3.6, and I don't have to go any further because it's just to the nearest 0.1, or the margin of error is smaller than 0. So if we do this together, this is just going to be a quick review actually. So this to the nearest 0.1, we have kind of a similar solution as the one before. So we first square the square root of 15.8, which we will get 15.8 itself. Then we know that 15.8 is greater than the square root of 2.9 and less than the square root of 4, which means that this will be greater than 3.9 and less than 4. So this is to the nearest 0.1. So this is close to either 3.9 or 4. For me over here, to the nearest 1, so really just to the nearest whole number, I would cube this and see, okay, this actually crosses out, and this is 1 times 200. 1 times 200 is greater than 10 cubed and less than 11 cubed, and right now it's the nearest 1, which means that I just have whole numbers here. So it means that this is in between 10 and 11, so it is about 10 or 11 to the nearest 1. Now we're going to be moving on to the next part of our lesson, using estimation to compare numbers. So here's an example. Using estimation, compare 1/2 and the square root of 5 minus 1 divided by 2. So we're going to be doing this together. If you really look at these two numbers closely, you will see that 1/2 right here is just a really simple number. It's a great fraction, but this has, it has square roots, it's minuses. So we're going to be comparing it. But what part of them is the same? Yes, you will see that over here, their denominators are the same. So when denominators are the same, it means that they are like fractions. Like fractions means that when you compare them, what do? Yep, that's right. You only compare the numerators. So whichever numerator is greater, then that number is greater. So really we have to compare the square root of 5 minus 1 and 1. So first, let's look at the range of the square root of 5. The square root of 5, if we square it, it's equal to 5. 5 is greater than 4, but less than 9. Even if it was 4, right? Even if it was 4, if you minus 1, it was already 2. It was already 3. So it just should come to us that this is ultimately greater than 1/2. So let's look at the computer solution to this. We first square the square root of 5. So we get that. So we know that square root of 5 is greater than 2 because 2 squared is equal to 4. So that means that the square root of 5 minus 1 is greater than 1, which also means that the square root of 5 minus 1 over 2 is greater than 1 over 2. So here's the method conclusion. Conclusion of comparing the magnitude of two irrational numbers with radicals. So we know that if A is greater than B, which is greater or equal to than 0, then remember how it has to be greater or equal to than 0. It can't be less than 0. then the square root of a is ultimately greater than the square root of b. That's rule number 1. And you should be writing this down in your notebook right now because it's one of the main important points of this lesson. All right, and for number 2, if a is greater than b, so then the cube of a, the cube of b, or a cubed is greater than b cubed. 3, if a, b are both positive, then a is greater than b, so a squared is also greater than b squared. So the following methods are used to compare radicals. 1. Estimate the approximate value of the radical first and then compare it with another number. 2. Compare by squaring both numbers. The idea of this method is to compare the square root. The larger the square root, the larger the arithmetic square root. 3. If they have the same denominator or numerator, compare the size of the numerator. Class summary. Today our main focus was estimation and the basics of estimating and estimating in the real world. 2 skills I hope that you are able to leave off with today is first understand the basics of estimation and able to use estimate to solve word problems. So thank you for watching this video and see you next time.